Cellular communication networks have evolved drastically over the last 4 decades, ever since the first generation of mobile communications was introduced. As the network grew, so did the demand for it. As more and more people wanted to be mobile phone users, there was a profit to be made here. So this led to an intense competition between different contenders trying to push their own technology. This competition and demand brought about new evolutions in the technology that have led to significant enhancements in performance with each new generation, due to the different innovations being developed and implemented.
1G was introduced in the 1980s. It was the first generation of analog cellular telephone. Analog transmission techniques were used to transmit voice signals. This network contained many cells, and each cell was covered by a radio network with one transceiver. The same frequency can be reused many times, which results in greater usage, which increases the system capacity, and a large number of users could be accommodated easily. Next, we have the 1G standards in different parts of the world. The first generation consists of various standards, which just uses frequency modulation techniques for voice signals. One of the standards is the AMPS, which is Advanced Mobile Phone Service, and in 1982 it was employed in the US and later in Canada, and also the ones from the list in the PowerPoint. The continuation for 1G standards in different parts of the world. We have TAX, ETAX, also we have NMT 450 and also NMT 900. For TAX, that stands for Total Access Communication System, and also it's related to ETAX, which is Extended Total Access Communication System. And these were employed in the United Kingdom and several more, which are on the list of the PowerPoint. And also we have for the MT450, we have Nordic Mobile Telephone. And also we have that listed as well in the PowerPoint. And for this slide, to end it, we have the Nordic Mobile Telephone 900. And also we have the list in the PowerPoint. Finally, for the first generation standards in different parts of the world, we have CNETs, which was employed in Germany, Portugal, and South America. CNETs, German, refers to the C network and was the first cellular wireless telephone here there in Germany. Also, we have the Radiocom 2000, which was employed in France. Also, we have the Radio Telephone Mobile System, RTMS, which was employed in Italy. And also we have the NTT, which was in Japan as well. Next, we have the second generation, which was introduced in the 1990s. Unlike the first one, the second generation was using digital systems, and it was using Global System Mobile, GSM, and it had a data rate up to 9.6 kilobits per channel. And also the global systems for mobile communication enabled data transfer on top of voice communication with speeds up to from 30 to 35 kilobits per second. The 2G advancements, we have the GPRS, General Packet Radio Service, and it operated on the similar 2G technology as GSM, with a few refinements which gave it a higher data speeds. And also we have the EDGE, Enhanced Data Rates for GSM Evolution, and this was introduced in 2003, and it was somewhat known to be the 2.9G or the 3G, because of its great advancement over GPRS and GSM. Next, we have the 2.5G. This technology comes between the second and third generations of the wireless technology. And for this, we have the GSM extension with enhanced data, GSM evolution, and also we have the GPRS, the first virtual data network using the Wireless Application Protocol, or WAP, and it was delivering up to 144 kilobits per second or through 84 kilobits per second with EDGE. The 2.5G describes the state of wireless technology and capability associated with General Packet Radio Services, or GPRS.
After the introduction of digital systems thanks to 2G, mobile phone users wanted to browse the internet and have higher clarity when speaking to other people. This need for higher data speeds could not be handled by 2G alone, so many competitors began pushing their own systems without anyone thinking about a unified standard. This led to the birth of different technologies such as CDMA 2001X, EVDO REV.O, and EVDO REV.B, including others as well. These all use the code division multiple axis or CDMA, much like some older 2G systems. Its parallel, the time division multiple axis, TDMA, was now being left behind. In the 2G era, two major access methods dominated, TDMA and CDMA. However, CDMA proved to be much more efficient and superior to TDMA, so when 3G came along, it used CDMA over TDMA. TDMA split the channel between devices into time and frequencies in which the devices would be able to transmit and receive, while CDMA used the same channel, in other words, the same time frequency resources, but each device was separated by being encoded through a spread code. It is much like multiple people speaking in a room, but they are all speaking a different language. This difference led to less wasted resources when using CDMA over TDMA, since when there would be lapses in a conversation, the time slotted would be wasted. However, in the case of CDMA, a brief lapse in the conversation would mean there is less interference, improving performance of the network. Eventually, TDMA was replaced by CDMA in all cellular networks in the US. While TDMA is still used in many parts of the world as a standard, due to its interoperability and widespread deployment, the CDMA method was implemented into all standard 3G networks, based on either the IS-95 or UMTS spectrum bands. Two major standards appeared from this: the third generation partnership project, which developed the high-speed packet access based off of WCDMA, and the third generation partnership project 2, which developed the CDMA evolution data only, based off of the IS-95 or CDMA 2000. These two standard bodies defined the new era of high-speed data by using the same CDMA waveform and carrier bandwidth, which were vastly superior to the older 2G systems. This was due to the adoption of CDMA over TDMA as mentioned before, and moving over to a wider bandwidth of 5 MHz, or WCDMA. Plus, their support of data packet communications was a major upgrade. This was achieved through using TDMA in the data flows within the cell on the downlink. In this table, we can see listed the different types of standards that were developed by the two bodies mentioned before, the 3GPP and the 3GPP2. The first three, CDMA 2001X, EVDO REV.O, EVDO REV.B, were developed by the 3G Partnership Project 2, and they're different variations of the same system. The bottom two use TDMA for their data flows, and they also have different modulations. Slightly different bandwidth, but this results in a pretty big difference in data rates. The bottom three, UMTS, HSPA, and HSPA++, were developed by the 3G Partnership Project. They also use CDMA and TDMA for the data flow, and the same modulation as the others, but they use more bandwidth, the WCDMA, as opposed to the other project which used the IS-95 bandwidth. This results in much larger data rates when you use more bandwidth. HSPA++ is actually an improved version of HSPA, which was termed 3.5G, which we'll talk about in the next slide. Throughout the revolution of the 3G era, new improvements were made to the existing 3G technology. It was coined the term 3.5G or Turbo G. The technology was called High-Speed Downlink Packet Access. As the name implies, it was an improvement on the standard developed by 3GPP, which used the WCDMA bandwidth. It improved on the data rates from the 2 megabits per second to a theoretical data rate of 10 megabits per second, or even as high as 20 megabits per second. This was achieved through the adaptive modulation encoding, multiple input, multiple output, hybrid automatic request, faster cell searching, and advanced receiver design. While the standard CDMA was still being used in new ways to achieve higher data speeds, it still had one major disadvantage. The signals being served by the same base station would often interfere with each other, and the handling of resources for data was not optimal, due to the differences it had between data traffic and voice traffic. For data traffic, high peaks are needed, but only for short intervals, so the resources had to be quickly allocated and then removed, depending on whether or not there was data to be sent. This led to CDMA eventually being replaced by orthogonal frequency division multiplexing, or OFDM. This would be the technology that the new 4G systems would implement.
Fourth generation wireless system is a packet-switched wireless system with wide area coverage and high throughput. It is designed to provide high spectral efficiency. The first successful trial for 4G was conducted in Tokyo, Japan back in 2005. The trial achieved 1 gigabits per second real-time packet transmission in the downlink at a moving speed at about 20 kilometers per hour. LTE and LTE Advanced wireless technology is used in 4G systems. The simultaneous transmission of voice and data is possible with LTE. Some key features include much higher data rate up to 1 gigabits per second, enhanced security mobility, meaning that data sent via 4G is encrypted, making 4G a lot safer, and 4G allows users to access the internet anywhere they receive signal. It also supports packet as well as message switching, frequency of 2 to 8 gigahertz, HD video access, and supports high speed, high capacity, and low cost per bit. 4G and 4G LTE is often referred to as the same thing, but this is incorrect. 4G is the next step above 3G, and 4G LTE is simply a type of 4G that delivers the fastest connection for a mobile internet experience. You can compare 4G LTE to the same experience you receive from your home router. Initially, 4G LTE wasn't available everywhere across the country. You had to not only make sure you have a device that supported 4G LTE, but you also had to make sure the location you're in provides it as well. But today, most mobile devices are 4G LTE compatible. 5G mobile technology is expected to give us the perfect real-world wireless service. 5G will further enhance the current system performance as well as provide additional capabilities. It will also offer faster speeds and more reliable connections on smartphones and other devices. The new 5G networks will require many more antennas than the previous networks. 5G is expected to offer data speeds faster than 1 gigabit per second. 5G networks are expected to launch in the year 2020. According to Verizon, its 5G network will most likely deliver speeds 200 times faster than the 4G LTE network today. Some fifth-generation concepts include pervasive networks. A user can be connected to several wireless access technologies and will have the ability to move between them. Group cooperative relay. This technique will make the high data rates available over a wider area of the cell. Currently, data rates fall towards the edge where the interference levels are higher and signal levels are lower. Cognitive radio technology. Cognitive radio technology will allow the user to choose specific parameters such as optimum radio access network, modulation scheme, and other parameters in order to obtain the best possible connection. Fifth generation architecture. The system model of 5G is a IP-based model designed for the wireless and mobile networks. The system consists of a main user terminal and then a number of independent and autonomous radio access technologies. Each of these radio technologies is considered as the IP link for the outside internet world.